So we're going to have to draw a picture, okay, in order to figure out what area are they actually talking about. So find the area of the region bounded by the curve and the line. First of all, what do you know about that curve? Yeah, it's n-shaped, isn't it? Because you have a minus. So it's an n-shaped curve. Now, we'd need to draw a rough sketch of that. So to draw a rough sketch of that, what would we need? Points. Where it cuts the x-axis is probably the easiest. So if you find the roots and then draw yourself an n-shaped graph, okay? So we're just going to say sketch. We know this is a quadratic and it's n-shaped, so all we need is the roots. So minus x squared plus 5x minus 4 is 0. That's how we find our roots. Now, to factorise this, we're going to change all the signs so that we have a plus x squared. Or from there, you can just do your minus b, totally up to you. So it's going to be 4 and 1, isn't it? 4 and 1, and factors of a plus are either a minus by minus, plus by plus. So x is 4 and x is 1. Now it's an n-shaped, something like that, okay? Now have a look at that line, y equals x minus 1. Does that have a positive slope or a negative slope? Remember, your slope is y equals mx plus c, so the m. So is that positive or negative? Positive. So it's going from left to right, up, okay? Now, I don't know where they cross, but I can find where they cross. I know basically my line is going like this, okay? How would I find the point of intersection of this curve and this line? So you can do simultaneous equation, or they're both equal to y, so equal them to each other. Yeah, okay? Basically, you're filling in, you're substituting in, anywhere you see y, you're putting in x minus 1. So x minus 1 equals that, okay? Sorry, find the points of intersection. I'm going to bring everything over here. Plus 5x comes over, becomes minus 5x. And minus 4 comes over, becomes plus 4. Factors of 3 are going to be 3 and 1, and they're both going to be minus again. Or you could do your minus b there. So x is 1, and x is 3. So I know the line and the curve meet when x is 1 and x is 3. So they actually meet there, and they meet somewhere like that. Now, is everyone all right with that? Okay. The question is, find the area of the region bounded by the curve and the line. It doesn't say anything about the x-axis. Okay? It doesn't say the curve, the line, and the x-axis. If it did, it would be, there's your curve, there's your line, there's your x-axis. It would be in there. It's just bounded by the curve and the line. So there's your line, there's your curve. This must be what they're talking about. So we know when we integrate, we get the area underneath a curve or underneath a line. Okay? So this one here is my quadratic, this one here is my line. How am I going to get the area? The area of what minus the area of what? The area of this one, the curve, minus the area under the line. Between what point and what point? Area under curve minus area under line. And what are your limits? 1 to?
Oh, from 1 to 2.
This one, 3, exactly, from 1 to 3. So I know it's the area under the curve, so that means integrate the curve from 1 to 3, and I'm taking away the area under the line, so that means integrate the line from 1 to 3.
How did you not go from 1 to 3?
So I had to find where they meet, and they met at 1 and 3, okay, those 2 points. There's no point going from 1 to 4, because then I'm also including all this bit, okay? But it didn't say anything about the x-axis. It actually just said the area between the curve and the line. And the area between the curve and the line is just this here, okay? Does that make sense?
Yeah.
Okay, so let's integrate. Minus x squared is going to be minus x cubed over 3 plus 5x squared over 2 minus 4x. You okay with that? And just integrate over there as well. And we know it's just finding definite integrals there. We're just going to fill in the 3, and we're going to take away the 1, fill in the 3, take away the 1. Okay, so and I'm taking away the 1. That's my first area. And I have to take away my second area, which is this, fill in the 3. And fill in the 1 and take it away. You following what I'm doing here? Yeah, you're all right? Okay. So this bit here is 3 over 2. So just throwing it into the calculator. Now, it's really important, in this scenario it didn't happen, but that when you're finding the area, you get an answer for this area, you get an answer for this area. Because if this area is a minus, what do you have to do with it? Make it a plus, and then you take it away. Okay, so don't get caught with those signs there. So you get 4 over 3. And it's area, so units squared.